final example, and we're going to do a little bit of an application. And we're in 7.1. We've been talking about prime factorization. We did GCF of just plain old numbers, GCF of monomials, and now we're going to apply everything we've learned and just kind of throw it in here into a word problem. So let's look at the top. I'm going to do the top about Garrison, and then you're going to do extra credit on the Adrian problem. Okay, so I'll give you 2 points for the Adrian problem if you can show me how to do it. I don't want to just see an answer. I want to actually see work on the bottom. That's true for everything that I ask you to do. I don't want to just see an answer, because you could have just called somebody and they write it, tell you, and you write it down. I want to see work, okay? So Garrison is creating a web page that offers electronic greeting cards. He has 24 special occasion designs and 42 birthday designs. The cards will be displayed with the same number of designs in each row. That is a very important sentence. I want to underline that, okay? The cards will be displayed with the same number of designs. Same number of designs in each row. Every row of cards is going to have the exact same number of cards in it. It's not going to be row 1 has 8 cards, but row 2 only has 5. They're all going to have, every row is going to have the same number of cards. That's crucial information there. Now, the special occasion and birthday designs will not appear on the same row. So we're not going to mix up the cards. Each row is going to be specific to that type of card. So the row, if it has a special occasion card on it, that whole row will be special occasion. If there's a birthday card, then that whole row will be birthday cards, okay? So here's what they want us to get down to. How many rows are we going to have if Garrison puts the greatest possible number of designs in each row? So we fill up each row to the maximum that we can. How many rows will that be? Okay, well, where we need to begin is how many cards are we going to put on each row, and then we'll figure out how many rows we need, okay? In order to do that, you are going to have to calculate the greatest common factor of 24 and 42, okay? And you can list them out. We know we've got 1 and 24, 2 and 12, 3 and 8, and then 4 and 6. Okay, so there's our list. And then 42, we know we've got 1 and 42, 2 and 21, 3 and I think 14, 4 doesn't work, 5 doesn't work, 6 and 7. Okay? And so I always start at the far end, and I don't see 42 on either list. I don't see 24 or 21 on either list. I don't see 14 or 12. I don't see 7, I don't see 8. Here's where I see the duplication. The first number, the biggest number where I see a duplication is 6. So that's how many cards we're going to put on each row. We're going to put 6 cards per row. Okay, because that's going to be the GCF of 24 and 42. Now, how many rows am I going to have of each? Well, of the special occasion cards, I have 24 designs, and I'm going to put 6 cards per row. So I'm going to need 4 rows of special occasion. Okay, did you see how I did that? I took the total number of designs I have and I divided it by my GCF. That's going to tell me how many rows I'm going to get. I'm going to do that with birthday too. I have 42 birthday designs, and I'm going to split them up in 6s. That means I need 7 rows of birthday cards for a grand total of 11 rows. So that's how much room I'm going to need. I'm going to need 11 rows for all these cards, all these designs that are created by Garrison. Okay? So I just showed you the top one about Garrison. Now what I want you to do is I want you to do this one for extra credit. It's very similarly structured. It's a different situation. It is about music, but it's very similarly structured, so please follow what I did. Find the GCF, then find the number of shelves that are needed, and then add up the total number of shelves so we can see how big the storage unit needs to be. Okay, bring your questions to class.